Imagine waking up tomorrow and looking at the night sky, only to see something enormous where the stars should be. A dark region of space so massive that even light cannot escape it. At first, nothing seems wrong. Your phone works. The sun rises. People go to work. But slowly, astronomers discover something terrifying. Earth is no longer safely orbiting the sun. Our entire solar system is being pulled toward a supermassive black hole. But here is the strangest part. We might not even notice it at first. Welcome back to Future and Fact Hub. Today, we're going on a journey into one of the most extreme scenarios imaginable. What if Earth was actually sucked into a supermassive black hole? Would we be destroyed instantly? Would time slow down? Could Earth somehow survive the journey? And what would the final moments of our planet look like? Let's find out. First, let's clear up one common misunderstanding. A black hole isn't like a giant cosmic vacuum cleaner that automatically sucks everything around it. If our sun were magically replaced by a black hole with exactly the same mass, Earth would continue orbiting almost exactly as it does now. The real danger comes when Earth gets extremely close to a black hole. Now imagine a supermassive black hole wandering into our region of space. Unlike the small black holes created by dying stars, a supermassive black hole can contain millions, or even billions of times the mass of our sun. These monsters usually sit at the centers of galaxies. One famous example is Sagittarius A*, the supermassive black hole at the center of the Milky Way. If Earth somehow began falling toward one, the first warning might come from the sky. Astronomers would notice strange changes in the motion of stars. Objects across the solar system would begin behaving differently. The orbits of planets could become unstable. Comets might be thrown toward the inner solar system. Asteroids could be sent flying through space. And eventually, scientists would realize that something unimaginably massive was approaching. At this point, humanity would have a serious problem. There is no realistic technology we currently have that could simply move Earth out of the way. Our planet has a mass of roughly 6 trillion kilograms. Moving it would require an almost incomprehensible amount of energy. As Earth gets closer to the black hole, gravity becomes stronger. But there is something even more interesting happening. Time itself begins to behave strangely. According to Einstein's theory of relativity, gravity affects the passage of time. The stronger the gravitational field, the slower time passes relative to an observer farther away from that gravitational field. So imagine two astronauts. One stays far away from the black hole. The other travels closer to it, to the astronaut far away. The clock of the approaching astronaut appears to tick increasingly slowly. From Earth's perspective, however, everything would feel normal locally. Your heartbeat would still feel normal. Your watch would still tick normally. You wouldn't suddenly feel time slowing down. But an observer watching Earth from a safe distance would see something very different. As Earth approaches the event horizon, our planet would appear to move slower and slower. And then comes one of the strangest effects in the universe. The light coming from Earth would become increasingly stretched toward longer wavelengths. This is called gravitational redshift. Earth would become dimmer and redder from the perspective of a distant observer. Eventually, Earth could appear to almost freeze near the event horizon. But that's only what a distant observer would see. For the people actually falling toward the black hole, the story would continue. Now, whether Earth is torn apart before reaching the event horizon depends heavily on the size of the black hole. This is where supermassive black holes become especially interesting. A smaller black hole has an extremely strong tidal force near its event horizon. The difference in gravity between Earth's near side and far side could stretch the planet dramatically. This process is often called spaghettification. Earth could be pulled apart. Oceans would rise violently. The atmosphere would become unstable. Mountains and continents would experience enormous stresses. Eventually, the planet could be stretched into a stream of matter. But with a supermassive black hole, the situation can be different. Because its event horizon is enormous, the gravitational gradient at the horizon can actually be much weaker than around a smaller black hole. That means Earth could potentially cross the event horizon without immediately being ripped apart. Think about how terrifying that would be. The entire planet could pass a point in space from which there is no possible escape. No rocket could turn around and leave. No laser beam could escape. Not even light itself could make it back out. The event horizon is not a physical wall. There is no solid surface waiting for Earth. It's a boundary in space-time. Once Earth crossed it, every possible future path would lead deeper into the black hole. But what would people on Earth experience? At first, perhaps surprisingly little. The sky could become increasingly distorted. Light from distant stars could appear bent around the black hole. The universe might look completely different. The black hole's gravity would act like an enormous gravitational lens, bending light around it. Stars could appear in strange positions. Some might form arcs or rings around the black hole. Imagine standing outside at night and seeing the stars stretched into giant glowing curves surrounding a region of absolute darkness. It would be one of the most spectacular sights humanity had ever witnessed. Unfortunately, it would also mean the end was approaching. As Earth moves deeper into the black hole, the gravitational environment becomes increasingly extreme. Eventually, even a supermassive black hole's tidal forces would become powerful enough to destroy the planet. Earth would begin to stretch. The oceans would no longer remain where they belong. The crust would crack. The atmosphere would be stripped away. Rocks would be pulled apart. The planet would lose its familiar shape. Earth would stop being a planet. It would become a stream of matter falling deeper into the black hole. But what about humanity? Unfortunately, humans would not survive this stage. Long before the planet was completely destroyed, the environment would become impossible for life. Radiation, gravitational stresses, geological destruction, and the collapse of Earth's atmosphere would make survival impossible. Civilization would disappear. Cities would be destroyed. Oceans would evaporate or be torn away. The atmosphere would escape. And eventually, Earth itself would cease to exist as a recognizable world. But there's another fascinating question. What happens to the sun? If the entire solar system were falling toward the same supermassive black hole, the sun would also be affected. Depending on the exact trajectory, the planets could be disturbed from their normal orbits. Some planets might fall directly into the black hole. Others could be thrown away at enormous speeds. Some might remain temporarily bound to the sun. The solar system could become a chaotic gravitational battlefield. And if Earth somehow crossed the event horizon while the sun remained outside, Earth would still be unable to communicate with it. Once Earth crossed the event horizon, any signal sent from our planet would be trapped. No message saying we're okay. No final radio transmission. Nothing could escape. From the perspective of someone far away, Earth would appear to slow down and fade away. But from Earth's perspective, the journey would continue. And eventually, according to classical general relativity, Earth would approach the black hole's singularity. This is where our understanding of physics reaches its limit. A singularity is predicted to be a region where matter is compressed to an extreme state, and the equations of general relativity break down. We don't actually know what happens there. Our current theories are incomplete. Scientists believe a theory of quantum gravity will eventually be needed to fully explain the deepest regions of a black hole. So perhaps the final fate of Earth isn't something we can accurately describe yet. Maybe matter is destroyed. Maybe information is preserved in a way we don't understand. Maybe our current picture of the singularity is fundamentally wrong. The truth is, we simply don't know. And that's what makes black holes so fascinating. They aren't just monsters that destroy planets. They are places where space, time, gravity, and physics itself behave in ways that challenge our understanding of reality. But let's take one final step back. What if the black hole wasn't moving toward Earth? What if Earth somehow traveled toward a supermassive black hole on its own? The result would still be catastrophic. The closer we got, the stronger the gravitational effects would become. The sky would become increasingly distorted. Time would behave differently relative to distant observers. Eventually, Earth would cross the event horizon, and there would be no turning back. So, could Earth ever actually be sucked into a supermassive black hole? Under normal circumstances, it's extraordinarily unlikely. The supermassive black hole at the center of our galaxy is approximately 26,000 light-years away. Earth isn't currently on a trajectory toward it, so you don't need to worry about waking up tomorrow and seeing our planet falling into Sagittarius, a star. But this thought experiment teaches us something incredible. The universe is far more extreme than anything we experience on Earth. Here, gravity keeps our feet on the ground. Around a black hole, gravity can reshape the paths of light and dramatically affect the passage of time. Here, 1 second feels like 1 second. Near a black hole, observers in different gravitational environments can disagree about how much time has passed. And here on Earth, escape is usually as simple as moving fast enough. Near a black hole, there is a boundary beyond which escape becomes impossible. Earth is tiny compared with the scale of the universe. Yet somehow, on this tiny planet, intelligent life has developed the ability to look into the darkness and ask questions about the most mysterious objects that exist. And perhaps that's the most incredible part of this entire story. We don't need to fall into a black hole to explore one. We can study them from millions and billions of light years away. We can observe how they affect stars. We can detect gravitational waves from black hole collisions. And with powerful telescopes, we can even observe the glowing material surrounding their shadows. The universe doesn't need to bring a black hole to Earth for us to understand how extraordinary they are. So if Earth were ever pulled into a supermassive black hole, our planet would eventually be destroyed, and humanity would have no way to escape once the event horizon was crossed. But until that impossible day, Earth remains our home, a small blue world floating through an enormous universe, filled with things we are still trying to understand. If you enjoyed this journey into one of the universe's darkest mysteries, subscribe to Future and Fact Hub for more mind-blowing what-if scenarios, space mysteries, futuristic science, and incredible facts about our universe. Because sometimes the most terrifying questions lead to the most fascinating discoveries.